Welcome to the Biosensors Research Laboratory at IIT Madras, where we develop technologies for healthcare, water and food safety, as well as pharma and chemical industries. "20 years ago, we may not have imagined home-based medical healthcare tests. These are blood glucometers, pregnancy test kits, even now COVID detection kits. No doubt we have gone a long way, but we still go to diagnostic laboratories to give a blood sample, and we have to wait to get test results either on the same day in the evening or the next day. But imagine our fellow country people in remote locations such as villages, or you want to have these tests done immediately so that you can actually start the treatment. These waiting times are not really good. So this requires a good technology, and this Biosensors laboratory is actually looking at developing these technologies so that they are affordable, sensitive, they can be deployed in primary healthcare centers. We make use of fiberoptic and nanotechnological tools to transform the conventional biological techniques into affordable, sensitive biosensing devices. These sensors work on the principle of simple optical absorption. So the light passing through an optical fiber is absorbed by the nanomaterial whenever the analyte of interest, which is a disease marker maybe, is present in a given sample. We have carried out an extensive research using conventional optical setups, and then subsequently we have gone to compact optical setups. We have realized a proof of concept, and we see that we are able to actually detect analytes of interest down to attomolar concentration, almost 150 molecules in 25 microliters. So this is detected by using a simple pair of an LED and a photodetector. We call this sensor as Plasmonic Fiberoptic Absorbance Biosensor, in short PFAB. The beauty of this technology is that it is so versatile, it can be applied for a range of biomolecules including proteins, DNA, RNA, a bacterium or a virus.
Tuberculosis incidence is very high in India. About 30% of cases are never diagnosed due to lack of simpler tests. To address this problem, PFAB technology is exploited to develop a sensitive TB screening test from a urine sample. As we all know, a reliable COVID diagnosis requires RT-PCR, but it is labor intensive and time consuming. Using PFAB technology, we have developed a low cost, rapid and sensitive COVID antigen test. Preeclampsia can be treated to save the life of mother and child when diagnosed early before 20th week of pregnancy. PFAB based screening test for early diagnosis of preeclampsia is under development. Vector-borne diseases such as chikungunya and dengue can be life-threatening. PFAB technology is highly promising for sensitive, accurate diagnosis for a timely treatment. This versatile sensor platform is highly suitable for the development of point-of-care diagnostic devices for a wide range of diseases at primary healthcare center level. Food and water contamination is an important concern for regulatory authorities as well as food processing units. The standard cell culture techniques take a long time to give out results. To overcome these limitations, we have come up with array fab technology for detection of multiple pathogens at a time. Detection of toxic heavy metal ion contamination requires sophisticated mass spectroscopic techniques. A fab-based technology is developed as an alternative with the help of a nanomaterial selective to these heavy metals such as lead, chromium, copper, etc. The fiber optic refractometers developed in the lab can be used to measure fat content in milk. They have potential to help the farmers earn a right price for their produce. Water contamination with endotoxins is a big concern for pharma industries and research laboratories. We have developed a strategy to detect this contamination using our PFAB technology.
The sensor probes are the workhorses of technology. We make these probes using simple optical fiber. We bend them using a machine we developed in the lab. We call it as fiber bending machine. We have developed a mechanism to hold these fibers in a cartridge so that the user can actually handle them in a very convenient way. Subsequently, these probes are subjected to chemical processes so that these bioreceptors for disease markers or pathogens or any other application can be modified. Chemical processes for large scale modification, surface modification of these probes is already in place, and subsequently we have developed point of care devices, very handheld compact devices, and at the same time we want to detect multiple analytes simultaneously in a given sample, or multiple samples detect them parallelly. So for this we have developed an array fiberoptic absorbance biosensor, we call it as RFAB, which is a compact device that can actually have multiplexed analysis about 8 samples or 8 analytes at a time. RFAB also uses a simple light source and multiple detectors, photodetectors, and we look forward to use these RFAB basically towards ovarian cancer detection or vector-borne diseases, and especially waterborne pathogen detection or foodborne pathogen detection. Fiberoptic refractometers are simple devices that enable measurement of refractive index of a given liquid in real time. These refractometers utilize very small volume, less than 25 microliters. They can be utilized in a process industry for real time monitoring of processes, or even for fruit juice monitoring, milk quality monitoring, or many other similar applications. To translate the technologies developed in the laboratory to bring them to the market, we have actually spun off a company by name Chem Biosense Private Limited. Chem Biosense is an R&D company mainly focusing on these technologies, making them viable for scale up as well as identifying the most suitable applications for immediate use. We are looking forward to interact with the industry leaders to utilize these technologies in order to develop relevant applications. Thank you.